Hello everybody, welcome to Physical Science. We're talking about the factor label method. And it's a way of doing math and making sure that the math is in the correct position before you do the math. So just want to make sure you know some math skills here. If we go 2 divided by 2, that equals 1, right? Just like if we go n divided by n equals 1. What if we had nm divided by n? That actually equals m, right? Because the whole thing is these cancel out. So we're left with something less than what we started with as far as the label. We're factoring out the label. What if we did something like this? We had nm, and then we have a factor over here, and we call these conversions. We also call these relationships. But if we had like 2L up here and we have an M down here, and this is stuff that I'm hoping you know from math, this cancels out because this is on bottom of the divisor line, and so it cancels out what's on top. So then our answer would be 2ln. Okay, so this is the kind of math that we're utilizing in the factor label method. So we're really just looking at what's up here, and if we're not happy with the label, we're going to have to put whatever part of that we're not happy with down here so we can factor that out and then be left with what we're going for. In this case, we preserve the n. Okay, so if you know and understand that kind of math, then we can move on. Okay, so we're going to talk about changing some SI numbers. So if we have like 44 millimeters and we want to know how many meters there are, well, there's an easy way to do that, and I know most of you have already done that in 8th grade and 7th grade. That'd be moving the decimal. So I'm going to teach you the next level of chemistry and physics math utilizing this, because we know that you can tell if the answer is correct in a different way. So we have to figure out how to look at this table. These are the tables that you often find in your books, and they're a little bit confusing, and I'll explain why. If you look at this, each power of 10 is going down by 1, except for right here, they're missing 1. Okay? So right here, there's no power of 10 labeled, and that power of 10 is 10 to the 0th, which is actually a 1. Okay? So that is going to come in handy here at some point, but I want you to put it on your tool so you understand what we're talking about. Now if you look at these are all names for prefixes, and those are used in front of the word, the base word, to tell what power of 10 we're using with the base. So another thing you got to know here is the base. Okay, so bases, common bases that we will use will be things like M for meters, L for liters, G for grams, S for seconds, and those are the most common bases. So for instance, how do these bases and these prefixes go together? Well, if I have a milligram, you can see here's the prefix, here's the base. Okay? Or I could have a microgram, which is what this is called. Here's the prefix, here's the base. So you notice the base is in the second position most of the time, unless you have a multiple letter prefix. But if I wanted to talk about megagrams, it's a big M and a little g. And so this is how this works. The base is always the last letter in there, and then the letters beforehand tell the prefix. Okay, so I want to make sure that you mark up your tool so you have these things on there. You'll be able to use this on the test. Another way you should mark your tool is somehow indicating that all of these numbers here should have a 1 times before them, and all of these numbers are always going with the base. So when we do the math, all these numbers are going to be going with the base, and it's going to have a 1 times in it. So if I'm looking at millimeters here, I see the number is 10 to the negative third. But the way I want to write this number is 1 times 10 to the negative third. And if we're dealing with grams for the base, then you would have that as the label. Because what that means is for every 1 milligram, there's 1 times 10 to the negative third grams. Now I know some of you understand this numbering system here, some of you don't. We're going to talk about that as well in another lesson if we haven't already done that. But for now we have to just learn how to work with these numbers. So let's use that one time. Let's say that we're going from 44 millimeters and we want to find out how many meters are in that. The very first step on all of these problems is write down what you know, and then you look to see what label you need to cancel out. And the label we're looking to cancel out here is mm. Okay, so I'm going to put that on bottom because I know if I divide mm by mm, it's going to cancel out. Now I want to look to the relationship between the prefix and the base, because that's what I'm going for, is the base here. And I always want to touch base for the first step. So I'm going to put that label right now so I know that the number that is with the base is in the correct position in order for this label to be canceled out, since I don't want that. So I find mm, here's the prefix. I find mm has 1 times 10 to the third associated with it. Now this base could be any base. For our use this time, it's going to be meters. So we'll go back to our problem, and we can say that for every 1 millimeter, we have 1 times 10 to the negative third meters. And then we can see that this cancels out. And then it's time to do our calculations, because we're left with the label that we're looking for. So now we can actually do the math. Okay, I have my scientific calculator up here, and this button right here, oops, I just lost my calculator. So the button EXP, so it's right here, that button right there, EXP, means times 10, and it waits for you to put in a power. You might have just a capital letter EE on your calculator. That will mean the same thing. So I'm just going to write that up here so you look for the right button. EE, and it could be second function, or EXP. These buttons are the most common. Another one might be times 10 and has a little dash up here. All of these three buttons mean the same thing. And what they do is they mean times 10, and they wait for you to put in the power that you want to indicate. So if you have a number before the times 10, which we do, our number is 1, you have to put that in first. So I'll bring up that calculator and I'll show you how to push the buttons to be successful with this. So we look to see our first number is 44, so you push 44, and then since the number we're calculating is on top of the fraction line, you push times. If it would be on bottom, you would push divided by. And then you put in 1, and then you push your EXP button, which puts in times 10, and then you push negative button, 3, and you can push equals then, and get your answer. And that is the correct answer for this problem. 0.044 meters is the correct answer. Okay, let's try another one. Let's say that we're going from 20 liters. Okay, that's the base now. We're trying to find out centiliters. Okay, so step 1, you start with 20 liters. You go to your first factor, and you realize that you have to get liters on bottom, so factors that out. And centiliters then is going to be on top here. Okay, so the question is 1 centiliter is how many liters? So you go to your tool and you find centi, okay? So I see centi right here. Here's centi, here's a little c, and that is, for 1 centiliter, it's equal to 1 times 10 to the negative second liters. So I go back over to this, and I've got 1 times 10 to the negative second liters is equal to 1 centiliter. We see the label cancels out, which is why we call it the factor out the label method. We're left with centiliter label, which is what we're looking for. So now we have to put this in our calculator. Notice, and this troubles kids. They seem to think that the number has to either go on top or on bottom. It can go either place. The thing is, the number has to go with the base. If you're following that table, the number always goes with the base. So let's look to see how we would calculate this. Okay, and we have 20, so I push 20. And then now the number's on bottom, so I have to push divide. And then I put in 1 exp negative 2, and I get an answer of 2,000, okay? And that is the correct answer, so it's 2,000 centiliters. Okay, so once you get a hang of that, I'll show you a two-step problem. And the two-step problem is when the base isn't in the question. So let's just say we're going from 20 milliliters, okay, so I've changed that, 20 milliliters to centiliters, okay, so there's no base in here. Liter would be the base, but it's not by itself. So now we have a two-step problem. Start the same way, and you put milliliters on bottom because that's dictated in order to cancel that out. And 1 milliliter is equal to 1 times 10 to the negative third liters. And I can see that gets canceled out. Now liters isn't what I'm going for, so I have to cancel out this. Now I have to cancel out this label, so liters has to go on bottom. And I'm going for centiliters, and I know that 1 centiliter is 1 times 10 to the negative second liters. And now I can see that I've canceled out my liter label, and I'm left with my centiliter label, which is what I'm going for. So now I do the math with this, and I can see that I push 20. I go to my first number, it's times, because it's on top, times 1 exp negative 3, and I push equals. Okay, so I'm done with that part, and now I go to my next number, and that number is on bottom, so I'm going to have to divide with the calculator. Okay, so I divide by 1 exp negative 2, and I get my final answer of 2. Okay, so 2 centiliters is the correct answer, and that's how you do a two-step problem. Like I said, there's an easier way to do this, but if you don't do it in the factor label method, you won't get the credit for the homework because this is what I'm teaching, not getting the right answer at this time. Hopefully this helps. Have a good day.